Section 13.4, Active Galaxies. Now, there are going to be quite a few different types of active galaxies. Only about 1 in 5 galaxies, as you can see, are extremely bright. That may be in visible light. It may be in other forms of radiation. But anyway, the first type that we're going to mention are called starburst galaxies. These are not really considered to be abnormal or anything in any way. They are undergoing a lot of star formation, as the name implies. Why? Well, it could be, for example, that they are currently merging with another galaxy. You could have a galaxy collision. Maybe they're just sort of absorbing a smaller dwarf galaxy. And we know that when galaxies collide, there's a lot of extra pressure on that dust and gas to make new stars. So starburst galaxies are ones that are pretty normal galaxies, but they are producing a lot of new stars. Nothing really unusual about this. A good example is M82. We saw this in the last section. We looked at two M81 and M82 examples of spiral galaxies. This was the one that we saw edge on, and it's nicknamed the cigar galaxy, and you see it here in the bottom right. So that apparently is a starburst galaxy, a lot of new star formation. Now, all the rest of the galaxies that we're going to talk about in this section are a little more exotic than the starburst galaxies. So, for example, Seyfert galaxies have very energetic galactic nuclei. The very centers of these galaxies are very, very active. You may already guess why. I won't say it just yet, but they have a lot of activity happening, a lot of energy coming from the center of these galaxies. And so here we see the fried egg galaxy. There's M82 again and the fried egg together. Okay. Some galaxies are called radio galaxies. Look at Cygnus A here. That's a pretty well-known one. Very strong radio source. And there's the galaxy right in the center that we actually see with the telescope, but way beyond it, going out over a vast area, you have these lobes, these radio emitting areas far from those galaxies. So those are called radio galaxies. This is a really cool one, Blazars. Now, we've begun to realize that blazars are not really something special. They're just active galaxies. We know that active galaxies, the energy tends to shoot out in jets. And blazars just happen to be lined up so that the jet is coming right at us. So that's why they seem to be particularly intense. They're lined up. I'm sure that's pretty rare, but they are lined up with us, the blazars. So if you had, for example, a radio galaxy and these lobes were pointed straight at us, you might call that a blazar. But really just a matter of semantics. It's nothing unusual. So here, for example, is this stream. This is from M87, the giant elliptical galaxy. We saw this in the last section as well. That stream of material coming out from the heart of that galaxy. If it was lined up just right, we'd call it a blazar. Now the term blazar may remind you of this term that you've possibly heard. Quasi-stellar radio sources, quasars. Quasars are pretty fascinating. Here are the facts. They are all ancient. All of them are very, very far away. There's not a single one we found within a billion light years of our solar system. So that's clue number one. They're very far away, which means they're very, very, very old. We're seeing them from billions of light years away. So they, are incredibly bright. They're actually the brightest things that we've seen in our galaxy. At one point, they thought they might be white holes, the other end of a black hole, but now we know differently. All right. We've found 30,000 of these so far. And obviously not in our galaxy, but in the entire universe, 30,000 of them. So what ties all of this together? You guessed it, supermassive black holes. They are the culprit behind all of these things. Radio galaxies, Seyfert galaxies, blazars and quasars, we think, are the result of black holes. Now, what's the difference between a quasar and the other thing? Well, they're older, and we think that supermassive black holes were more active when they first formed billions of years ago. So quasars are really the beginning of supermassive black holes, if you will, when they were kind of gobbling up everything in their area. What we think happens is after a while, things die down because they've sort of cleared out their area. They've cleared out their neighborhood, and a supermassive black hole like the one in the Milky Way is pretty quiet these days. But long ago, in the age of quasars, there was a tremendous release of energy as supermassive black holes were forming. And check this out. We've actually seen quasars colliding. I mean, just imagine that. And these supermassive black holes may actually then merge to form an even larger black hole. It's just crazy, crazy stuff. Speaking of crazy, next section we'll talk about galaxy clusters. Thanks for listening.